A few days ago, I asked on my social media if you like to see how I transformed this Gastly made in Desmos into a shader in Godot, and these were some of the comments. So, welcome to the very first episode of my channel. Today we are going to recreate this procedural Gastly in Godot. First, we will work with inequalities and mathematical equations in Desmos to build the basic shapes. Then we'll translate those same operations into Godot Shader's language, GDSL, to render the character on a QuadMesh. Here I have my starter template. As you can see, the noise calculations we'll use to generate Gastly smoke are already included. I'll leave this template in the description so we can all start from the same point. Gastly is a relatively simple character from a geometric point of view. It's basically a sphere with two eyes, a mouth, a pair of teeth, and the characteristic smoke surrounding it. Representing these shapes using mathematical equations is pretty straightforward. For example, we can define a circle using the following equation. In Desmos, we can express this equation as an inequality to visualize the interior region of the circle. As we can see, the circle appears centered on the grid, which is mathematically correct. However, when working with shaders, we need to think in terms of UV space, where the coordinates are usually defined in the 0 to 1 range on both the U and V axis. So the first thing we'll do is to take the XY coordinates, which in this context is the same as saying UV. We'll separate them like this. Next, we'll add a few constant values to make sure Gastly's shapes stay stable over time. Finally, we'll paint the resulting area black. And that's it. With this, we already have Gastly's body. Now we can start drawing the smoke. For that, we'll use the P function, which is located inside the gradient folder. This function implements a smooth bilinear interpolation between random gradients, producing what is commonly known as Perlin noise. As arguments, it takes the XY coordinates. With this function, we can generate the following result. However, once again, we'll need to center the smoke inside the UV space. We'll also make the smoke a bit smaller. To do that, we simply multiply the result of the function by a constant value, for example 0.25. Gastly's eyes can be described as circles cut in half. However, because they are drawn in perspective, it's more convenient to represent them using ellipses instead of circles. To define an ellipse, we can use the following equation. In Desmos, this equation will look like this. By the way, if you're a Godot fan, many of these techniques are fully documented in our book, The Godot Shader's Bible, which you can find on Gastly and Amazon. This book is ideal if you want to get started in the technical art because it explains, step by step, the concepts needed to understand how a pixel is actually drawn on the screen. It also includes practical exercises like building a depth effect for an anime-style eye or creating a volumetric cloud using shaders. If you don't have it yet, I've included a discount coupon for the digital version. You can find the link in the description. Now, going back to Gastly's eyes, we'll need to add limits to both shapes in order to get the correct form. In Desmos, these limits are defined using brackets, where we include the conditions that restrict the equation. In this case, we could use expressions like this. For the pupil, we can once again use an ellipse for each eye. In this case, we don't need to define any additional limits. Now the question is, how can we draw the mouth? One simple solution is to draw another ellipse, but limit it using a second ellipse, which allows us to control the final shape of the mouth. We can achieve this in the following way. First, we draw an ellipse. Then inside brackets, we limit that ellipse using a larger ellipse. The result looks pretty good. Now we can add the teeth. For this one, we can use a simple inequality. For example, if we define y greater than x, we get a diagonal line. Now, if we compute the absolute value of x, we get two diagonals. If we adjust the coordinates using a few constant values, for example, y less 0.32 greater than the absolute value of 3 times x less 0.91, we can approximate the shapes of Gastly's tooth. However, we'll need to add an additional limit to make sure the tooth doesn't extend beyond the mouth. To do that, we can reuse the same ellipse we previously used to define the mouth. We simply copy and paste the restriction. Even then, the tooth still extends into an area we don't want to keep, so we'll add one more limit to remove that region, and that's it. For the second tooth, we can apply exactly the same process. First define the diagonals, then add the corresponding limits. At this point, our Gastly is almost ready. To finish it, we'll add a distinct line that appears under the left eye. We can create this line using two circles, where one masks the other. The same effect could also be achieved using two ellipses. For this case, I'll use one circle for the shape and another circle as the limit. At this point, we could say that Gastly is finished. However, the character looks very static, so we can add a bit of movement over time. Doing this in Desmos is pretty simple. First, we'll declare a variable with a range between 0 and 10. As you can see, we can animate this variable just by pressing the play button next to it. The movement we want is basically up and down, and we can achieve that using the sine function. Here's what we'll do. We declare a new variable that stores the value of sine. Then we include the variable s1 in the y coordinate, using a as a parameter. If the movement feels too fast, we can adjust the speed in the animation settings. In my case, I'll set the speed to 0.1. If we play the animation, we'll notice that the movement feels a bit unnatural. For that reason, I'll create a new variable called s2, which will allow us to offset the motion in some parts of the character. The first thing I'm going to do is add a small animation to the character's right eye. Now the movement feels a lot more natural. Yeah, looks better, right? Now I'm going to add animation to Gastly smoke. To do that, we can simply subtract the variable a from the first coordinate of the function. As you can see, the character is starting to come to life. However, for the pupils, we need to define a maximum value, otherwise they will grow too much. In this case, we can use the max function to set an upper limit. Yep, the result is looking pretty good. Now we need to translate all this into a shader in Godot. To do that, I'm going to create both a shader and a shader material inside my project. To keep things simple, I'll name both of them Procedural Gastly. The reason we are using a shader material is that this type of material doesn't come with predefined properties. Instead, we can define them manually using GDSL code. Before we begin, it's important to clarify something. This implementation is not meant to be used directly in a production game. However, exercises like this help to strengthen our understanding of coordinates, spaces, and function manipulation, which are the real foundation behind shaders. With that said, let's start the implementation. I'm going to jump into the fragment stage, and the first thing I'll do is define the variables a, s1, s2, and the UV coordinates. In this case, since a represents time, I'll write it as t inside the shader. I'll also set it equal to the time variable multiplied by 0.25, so it behaves similarly to what we had in Desmos. As for the UV coordinates, there's one important difference we need to keep in mind. In Cartesian coordinates, the origin is located at the center of the space. In Godot, however, the UV origin is located at the top left corner of the QuadMesh. So the first thing we need to do is flip the B coordinate of the UVs so we can get the same result we had in Desmos. Once that's done, we can start defining Gastly's different shapes. Let's begin with the smoke. Here's what I'm going to do. I'll use a noise texture to recreate the general shape of the smoke. This texture could have any name, but in my case, I'm going to call it main text. As for the texture, I'm going to generate one directly from this website. I think a resolution of 512 x 512 will be enough. By the way, you can find the link of this website in the description. Next, I'm going to declare a function called smoke, which will take two arguments, the UV coordinates and the noise value. Once that's ready, we can define the smoke shape inside the fragment stage. If we save the changes and assign the textures to the material, we'll see that the smoke is projected perfectly onto the QuadMesh. However, Gastly is made up several shapes and colors. Because of that, I'm going to declare a new vector called render, which I'll use to build the final shape of the character. Now I'll continue with the body. For that, I'm going to declare a new function called body, where I'll use the same values I used earlier in Desmos. As for the radius, I'll use the value 0.06, which is an approximation of 0.25 square. It's also worth mentioning that the POW function is usually relatively expensive for the GPU, so if we can avoid it, that's generally better. Now we can add the body shape to the final result. To do that, I'll declare a new variable called bodyShape, where I'll store the result of the body function. Finally, I'll add the bodyShape variable to the render vector, which will let us display both shapes on the QuadMesh. Before defining the rest of the character's shapes, I'm going to declare 3 color vectors, each one matching Gastly's characteristic color tones. Then I'll include these variables inside the render calculation like this. Our character is starting to take shape. Next, I'll declare a function to build the left eye. Once again, this function is simply a translation into code of the operation we previously defined in Desmos. For example, if we compare both implementations, we'll see they use the same numbers and the same functions. Once the function is defined, we can create a new variable and eventually add it to the render. In this case, I inverted the operation because the original result produces white outside the eye and black inside, which is the opposite of what we need. Before continuing, I'll set this shader to unshaded to ensure that lighting doesn't affect the QuadMesh. Better, right? Now, let's continue with the right eye. Once again, I'll translate the functions we defined in Desmos into code, which in GDSL will look like this. After that, I'll declare a variable called rightEyeShape, where I'll store the result of this function. To display the eye on the QuadMesh, we need to add it to the render. We can do that following the same approach we have been using so far. At this point, our character is starting to look pretty cool. Now we only have the pupils, teeth, mouth, and the line under the eye left to add. To add the left pupil, we can repeat the same process as before, declare a new function and include its value from Desmos, initialize a new variable to store the result of that function. And then add the variable to the render. For the right pupil, we can do exactly the same thing, we just need to keep in mind the values we used earlier in Desmos. Let's keep going by adding the function that will allow us to draw the mouth. To do that, we can do the following. Then we declare the variable to store the result of the function. And finally, add the shape to the render. In this case, I'm using a linear interpolation or mix. Why? Because the render already contains the previous values. We only need to add the shape of the mouth and color it. For the left tooth, we can include the following function. Then we declare a variable to store the function's result and finally add the tooth to the render. As you can see, this process is pretty repetitive, so now I'll show you the solution I created for the right tooth and the line under the eye. Then I declare and initialize two variables with their respective results, and finally added those shapes to the render. As a final step, I made sure to clamp the final render value to guarantee that all values stay within the 0 to 1 range. At this point, we can say our character is finished. However, there is still one crucial step left, adding the alpha. To do that, I'll declare a new variable called alpha and pass in the values from the smoke, the body, and the right eye. Since this sum exceeds the maximum luminance allowed for a pixel, I'll clamp the result again, so the values stay between 0 and 1. And now's your turn. What do you think about the result? Would you like to see more content like this? If you have an idea for a shader, leave it in the comments. On my social media, I've shared several effects you might like, so in the next video we could recreate one of those as well. And that's it for this video. See you in the next episode.